The Sun is perhaps the most important celestial body when it comes to the survival of life on Earth. Without its nourishment, our planet would be a frozen wasteland where humans would cease to exist. This makes the Sun an important area of study for scientists, but little was known about the surface of the star until now. For the first time in history, a spacecraft has touched the Sun. NASA's Parker Solar Probe has flown through the Sun's upper atmosphere, the corona, and sampled particles and magnetic fields there. Let's talk about some of the biggest discoveries made by the probe. Launched on August 11, 2018 from Cape Canaveral, Florida, the Parker Solar Probe is designed to study how heat and energy move through the Sun's corona and explore what accelerates the solar winds that affect Earth and other planets. It is named after Eugene Parker, who first hypothesized that high-speed matter and magnetism constantly escaped the Sun and that it affected the planets and space throughout our solar system. This phenomenon is now known as solar wind. The mission is expected to make 24 orbits of the star before swooping into the outermost part of the solar atmosphere to study the Sun up close and personal. At its closest approach, the Parker Solar Probe will fly within 3.7 million miles of the Sun's surface, more than 8 times closer than any other spacecraft and more than 8 times closer than Mercury. It's a spacecraft loaded with technological breakthroughs that will solve many of the largest mysteries about our star, including finding out why the Sun's corona is so much hotter than its surface. Originally known as Solar Probe Plus, the Parker Solar Probe set out to solve 2 outstanding mysteries of the Sun's atmosphere. The first involves the corona, where temperatures are higher than those found at the surface of the Sun, a process that seems to break the laws of nature. The high temperature remains a mystery more than 60 years after it was first measured. The second mystery involves the solar wind. The fast, hot wind blows charged particles, but its origin remains unknown. There is no organized wind close to the Sun's surface, but by the time it hits Earth, the wind blows incredibly fast. Somewhere between, an unknown agent accelerates the wind. Scientists hope that the new mission will help identify the driving force. On April 28, 2021, the Parker Solar Probe became the first spacecraft to touch the Sun. The announcement was made by scientists at the American Geophysical Union meeting in New Orleans. They said the Parker Solar Probe flew through the Sun's corona, which is that fiery-looking outer layer of the Sun that appears around the Moon's silhouette during total solar eclipses. Parker Solar Probe has been sampling the corona's particles and magnetic fields. This has allowed it to make discoveries that more distant spacecraft can't make. Unlike Earth, the Sun doesn't have a solid surface, but it does have a superheated atmosphere made of solar material bound to the Sun by gravity and magnetic forces. As rising heat and pressure push that material away from the Sun, it reaches a point where gravity and magnetic fields are too weak to contain it. That point, known as the Alfvén critical surface, marks the end of the solar atmosphere and the beginning of the solar wind. Solar material with the energy to make it across that boundary becomes the solar wind, which drags the magnetic field of the Sun with it as it races across the solar system to Earth and beyond. Importantly, beyond the Alfvén critical surface, the solar wind moves so fast that waves within the wind cannot ever travel fast enough to make it back to the Sun, severing their connection. Until now, researchers were unsure exactly where the Alfvén critical surface lay. Based on remote images of the corona, estimates had put it somewhere between 4.3 to 8.6 million miles from the surface of the Sun. Parker's spiral trajectory brings it slowly closer to the Sun, and during the last few passes, the spacecraft was consistently below 8.6 million miles, putting it in the position to cross the boundary, if the estimates were correct. During its 8th flyby of the Sun, the probe encountered the specific magnetic and particle conditions at around 8.1 million miles above the solar surface that told scientists it had crossed the Alfvén critical surface for the first time and finally entered the solar atmosphere. This brought with it some interesting discoveries. During the flyby, Parker Solar Probe passed into and out of the corona several times. This has proved what some had predicted, that the Alfvén critical surface isn't shaped like a smooth ball. Rather, it has spikes and valleys that wrinkle the surface. Discovering where these protrusions line up with solar activity coming from the surface can help scientists learn how events on the sun affect the atmosphere and solar wind. At one point, as Parker's solar probe dipped to just beneath 6.5 million miles from the sun's surface, it transited a feature in the corona called a pseudo-streamer. Pseudo-streamers are massive structures that rise above the sun's surface and can be seen from Earth during solar eclipses. Passing through the pseudo-streamer was like flying into the eye of a storm. Inside the pseudo-streamer, the conditions quieted, particles slowed, and several switchbacks dropped. This was a dramatic change from the busy barrage of particles the spacecraft usually encounters in the solar wind. For the first time, the spacecraft found itself in a region where the magnetic fields were strong enough to dominate the movement of particles there. These conditions were the definitive proof the spacecraft had passed the Alfvén critical surface and entered the solar atmosphere, where magnetic fields shaped the movement of everything in the region. The first passage through the corona, which lasted only a few hours, is one of many planned for the mission. Parker will continue to spiral closer to the sun, eventually reaching as close as 3.83 million miles. Even before the first trips through the corona, some surprising physics were already surfacing. On recent solar encounters, Parker's solar probe collected data pinpointing the origin of zigzag-shaped structures in the solar wind called switchbacks. The data showed one spot that switchbacks originate is at the visible surface of the sun, the photosphere. By the time it reaches Earth, 93 million miles away, the solar wind is an unrelenting headwind of particles and magnetic fields. But as it escapes the sun, the solar wind is structured and patchy. In the mid-1990s, the NASA European Space Agency mission Ulysses flew over the sun's poles and discovered a handful of bizarre S-shaped kinks in the solar wind's magnetic field lines, which detoured charged particles on a zigzag path as they escaped the sun. For decades, scientists thought these occasional switchbacks were oddities confined to the sun's polar regions. In 2019, Parker discovered that switchbacks were not rare, but common in the solar wind. This renewed interest in the features and raised new questions. Where were they coming from? Were they forged at the surface of the sun, or shaped by some process kinking magnetic fields in the solar atmosphere? The new findings finally confirm one origin point is near the solar surface. The clues came as Parker orbited closer to the sun on its sixth flyby. Data showed switchbacks occur in patches and have a higher percentage of helium, known to come from the photosphere, than other elements. The switchbacks' origins were further narrowed when the scientists found the patches aligned with magnetic funnels that emerge from the photosphere between convection cell structures called supergranules. In addition to being the birthplace of switchbacks, the scientists think the magnetic funnels might be where one component of the solar wind originates. The solar wind comes in two different varieties, fast and slow, and the funnels could be where some particles in the fast solar wind come from. According to scientists, the structure of the regions with switchbacks matches up with a small magnetic funnel structure at the base of the corona. This is what was expected from some theories, and it also helps pinpoint a source for the solar wind itself. Understanding where and how the components of the fast solar wind emerge, and if they're linked to switchbacks, could help scientists answer a long-standing solar mystery: how the corona is heated to millions of degrees, far hotter than the solar surface below. While the new findings locate where switchbacks are made, the scientists can't yet confirm how they're formed. One theory suggests they might be created by waves of plasma that roll through the region like ocean surf. Another contends they are made by an explosive process known as magnetic reconnection, which is thought to occur at the boundaries where the magnetic funnels come together. While the probe has made some astonishing discoveries about the sun already, it continues to orbit the star to this day, getting closer to its surface with each passing flyby. This incoming data will surely help us further our understanding of the star that makes all life possible on Earth. If you enjoyed this video, you may also like this one, which talks about this solar system that has 3 stars. Please remember to like, subscribe, and hit that bell icon for more content about the mysteries of space. Do you think we should send more missions to study the sun? Please share your thoughts in the comment section below.